Hi everyone, welcome to the video over compounding continuous notes. So this right here is our formula for compound continuous. So as a reminder that E is a number. So we can see what number it is if we go to our calculator and we go to a new calculator, add a calculator, we do E to the first power and we see that it's about 2.71. Okay, so just a reminder, E is a number, so again it's about 2.71. So A is going to represent our ending balance. P is going to represent our principal balance or our starting balance or our initial amount. R represents our rate as a decimal. And T is going to represent our time, and we're going to make sure that it's in years. So looking at example number 1, how much money would be in an account after 11 years with a principal balance of $6,000 and an interest rate of 3.2% if the interest is compounded continuously? So first off, it has to say compounded continuously in order to use our formula A equals P times E to the RT power. Once it says that, then you can use that formula and start identifying your different parts. So first thing, it says after 11 years. So that means that our time is going to be 11. Okay, it says that it had a principal balance of $6,000. That is our starting amount, so that's going to be P. And then it gave us an interest rate of 3.2%. Well, we can't use 3.2% as our rate. What we would need to do is move our decimal places 2 places to the left, and that would give us 0.032%. Now that we have all of our variables, we can go ahead and plug it in. So we have A equals 6,000 times E to the 0.032 times 11. And now we're just going to type this part in to our calculator. So we go over to our calculator. We have 6,000 times E to the 0.032 times 11 power. Press enter. Oops, I hit it twice. We get $8,531.45. And that would right there would be our answer. So after 11 years of it just sitting in this account, compounding continuously, okay, the ending balance or the future value would be $8,531.45. Going on to the next one, if you want to pause the video and try part A, go ahead and do so. So you deposit $3,000 into an account that pays 3.5% annual interest compounded continuously. So again, it says compounded continuously, which means that we can use our formula A equals P times E to the RT power. We start identifying our variables. So you deposit $3,000 in an account. So that tells me that my principal is $3,000. It says that it pays 3.5 annual interest. So my rate, again, we move the decimal places 1, 2 places. We get 0.035. And the time it tells us after 3 years. So we go ahead and plug those numbers in. And we go switch over to our calculator. and we get $3,332.13. And that would be the total after 3 years. Now, looking at Part B, it's a little different. How many years would it take to get a balance of $3,701 round to the nearest tenth? So we have a new number right here. This is assuming that Part A never happened. So we still have our principal at $3,000. We still have our rate at 0.035, but now we have our ending balance of $3,701. Okay, so we're searching for how long it would take, so we're searching for the time. That's what we don't know, and we want to make sure we round this to the nearest tenth. So we're still going to use the A equals P times E to the RT power formula. We're going to plug in the values that we have. So we have 3,701 equal to 3,000 times E to the 0.035 times T power. Okay, so our goal is to get the E to the power by itself. So we're going to start by dividing by 3,000. So when we do that, we get 3,701 over 3,000 equals E to the 0.035 T power. Again, leaving that as a fraction is just going to make it easier for us so we don't have to write down a bunch of decimals. Okay, so now it's to the point where there's nothing left we can do. So we're going to go ahead and switch it to logarithmic form. So when you get to a point of solving in exponential form and there's nothing left, you just switch it to the other form. So my base is E. When the base is E, you use the natural log. My number would be the fraction that we have. So that's going to go with the natural log. And we're going to set it equal to the power or the exponent. Like that. Now, before we do anything else, I'm going to go ahead and divide out the 0.035 on both sides. That way we can just type it all in at once and solve for T. So now we're going to move to our calculator so we can solve for T. I am going to type this part right here into the calculator. Okay, so when we go to our calculator, start with the fraction button. Up top, we're going to have the natural log. You'll hit Control E to the X. And then within the natural log, you're going to have another fraction. So 3701 over 3,000. And then in the very bottom denominator, it is 0.035. So it should look like this when you type it in. You press enter. You get 5.99974. We want to round to the nearest whole number, which would be 6. So it would take about 6 years for this bank account to get to $3,701. So if you have any questions over compounding continuous, please send me an email so I can help you out or ask me in class. And I will see you in the next video.